Okay, today we're going to be looking at section 1.5 in your textbook on page 42. There's nothing new about this in regards to what you've already learned, okay? The only difference is now that we're dealing with word problems, primarily. We've already done several word problems with elimination, but these ones are a little bit more complicated. So starting on page 40, let's say 43. So there's a few ways we can solve systems by linear equations. So we can either solve them algebraically. What are the other two ways that we've learned on how to solve equations or systems? Yeah, and
Graphically.
Good. Graphing is one, and the other one, besides elimination, yeah,
Substitution.
substitution. Good. So those are the three that we need to know. In these word problems, it doesn't tell you specifically whether you should solve it using substitution, elimination, or graphing. So it's kind of left up to you. But I would suggest, if it is up to you and you can choose, I would always suggest elimination. It tends to be the easiest, okay, unless you're given graphs. Example 1. So this is on page 43. Can I have a volunteer to read? Yeah, I'll read. Thank you.
Christian has a total of 8 cars and trucks to play with. His birthday is soon. He hopes to double the number of cars he has now. If he does, he will have a total of 11 cars and trucks. How many cars does he have now? How many trucks?
Good. So if we wanted to, let C represent the number of cars Christian has now, we can say that his cars and trucks make a total of 8, right? It says he has a total of 8 cars and trucks. So C plus T is equal to 8. Okay, and if he wants to double the number of cars he has now, it's going to be 2C plus the same number of trucks is equal to 11. So it's a pretty simple equation here. We have our cars plus our number of trucks is equal to our total number. And double the amount of cars now plus our trucks is equal to 11. So here we should be pretty familiar with what to do if this is equation 1 and this is equation 2. We're going to multiply equation 1 by 2. So we're going to write a little 1 times 2 here. And I wouldn't actually write that equating line yet. I'll leave that blank here. So now we have them lined up. We have 2C and 2C. So now we're going to subtract these two. So 2C minus 2C, these go away. T minus 2T, so we'll have minus T is equal to minus 5. So then we have T is equal to 5. So if our number of trucks are 5, we can then sub into 1. So we would have C plus 5 is equal to 8. C is equal to 3.
Sure.
Yeah.
Wouldn't you just subtract T from T because they're already the same?
Yeah, you're right. You could have done that. Sorry, I didn't see that. You could have just subtracted these two immediately. Yeah, good. Yeah, same thing. You would have got the same answer. Okay? But yeah, one less step. So definitely might want to have done that first. So we know that Christian's cars and trucks, he has 6 cars will be doubled. So from the original 3, he'll have 6. And he also has 3 cars and 5 trucks now. Okay, pretty simple problem. Number 2, this is on page 44. So this gets a little trickier. I'll have John Luca read. It's on page 44.
Lewis took 2 hours to travel to Florida with the train trip against the current took 3 hours. What was the average handling rate of the canoeist? What was the speed of the current?
Good. So this one's a little trickier. Okay, we have to think about it. If we're going to let P represent the canoeist's average paddling speed, and C can represent the current of the water. All right, so one thing we do need to remember is that our distance so if you guys remember this triangle from science, you can read it this way. Distance is equal to speed times time, or speed is equal to distance over time. So you actually need to know that for a lot of these questions. Okay, so if you haven't already have that memorized, then you should have a triangle like that memorized.
So can you say it again?
So this triangle represents speed, distance, and time. So speed is equal to distance over time. Time is equal to distance over speed, and distance is equal to speed times time. Okay? Should look familiar to you guys. So it depends on what we're actually solving for. In this particular case, we know that distance is the same. So distance is equal to speed times time. So we're always going to say, in either scenario, our distance is 12. So we can say 12 is equal to, when we're going with the current, it's our paddler's speed plus the current speed. So that's our speed times our time. So in this case, it takes us 2 hours. Okay, so when we're going with the current, that's our formula. When we're going against the current, we have our paddler's speed minus the speed of the current times 3 hours. Okay, so there's our two formulas. And you could have put this 2 at the front or this 3 at the front. Either way, it's multiplication. All right, so I'm going to expand now and simplify these two. So we have 12 is equal to 2p plus 2c. So right now we have two equations. Neither of the variables are the same, so I need to multiply the first one, let's say, by 2, and the second one by 3. Or sorry, the first one by 3, second one by 2. Now I have my coefficients the same, so I can either eliminate my p's or eliminate my c's. The first question says, what was the average paddling rate of the canoeist? So we want to solve for p, so let's add to eliminate the c's. So 36 plus 24. These are going to get added, so we have 12p. That is 5. Yeah. So our average speed of the canoeist is 5, and that would be in kilometers per hour. So the average this would be paddling speed. Now to find the current, we would just sub that into our equation. 12 is equal to 2 times 5 plus 2c. So 12 minus 10 is 2. So the average current is 1 kilometer per hour. Any questions there? All right. Moving on to example 3. Okay, this is probably the most common word problem that you'll see in this textbook, and it's probably one of the more challenging. So we see this with all different types of problems. It's a percentage problem though. So chemistry is a typical application for this problem where we're talking about different solution concentrations. So let's read at the top there, example 3. This is on page 45. Andy?
Maram has a bottle of 5% acetic acid and a bottle of 10% acetic acid. How much of each should she use to make 250 milliliters of 8% acetic acid?
Okay, good. So there's a lot of numbers that are thrown out here, a lot of different percentages. It's important to understand what each one represents. All right, so you need to come up with a variable that's going to represent your 5% acetic acid and your 10% acetic acid. So it could be whatever you want to call it, whatever letter you want to use. In this particular case, because it's 5, they use the letter F. Okay, so it's important to realize that though. It's not, they're both acetic acid, but the F is actually representing the solution that has 5%. That's why it's F. And T they use for the 10% acetic acid. So we know that all of our 5% F plus our 10% has to be equal to 250. Okay, so this is strictly a volume equation. So dealing with the volume, the total volume of our 5% acetic acid plus the total volume of our 10% has to be equal to 250 milliliters. So that's the easy one. The second part is now we're going to look at just the amount of acetic acid. So if the first one, 5%, we know when we want to convert a percentage to a decimal, we divide by 100. So that's going to give us 0.05. So whatever the amount of volume of the 5% acetic acid, we're going to multiply that by 5% or 0.05. That'll give us the total amount of acid, acetic acid. Okay, because this is a percentage of acetic acid and this is the actual volume. So 0.05 times F plus 0.01 times T. That's going to give us our total volume, which creates a mixture of 0.8%, so 0.8, and that's times 250. Okay, so it's a little bit tricky. You have to understand that this is a volume equation, relating our two variables strictly to the volume of 250 milliliters. And then this is an equation that's actually calculating the amount of acetic acid. A very specific acetic acid. So it's 5% of this volume plus 10% of this volume is equal to, gives you a total of 8% of the total volume. Okay, that's where the two equations come from. Any questions there? Because that's definitely the hardest part. No questions? Okay, so we're going to now work this out. They actually use substitution in this case. So you can use substitution or elimination. Because they're dealing with decimals here and we already have an equation that's set up like that, they say, well, F is just going to be 250 minus T. I believe they use F as the substitute. Yeah, so that is our value of F, and now they substitute that in for F in the second equation. So 0.05 times F is 250 minus T. So we get a value of T is 150, and we can substitute that into the first equation. So we have F plus 150 is equal to 250. We have F is equal to 100. So remember now, this is our volume equation, so we know F is 100 milliliters, T is 150 milliliters. So, Miriam, So she should mix 100 milliliters of 5% acetic acid and 150 milliliters of 10% acetic acid to produce 250 of 8% acetic acid. Any questions there? Yeah, Matthew?
Wouldn't it be negative 0.04?
Negative, 0.04. Well, because this is 0.1 positive and this is negative 0.05. So when you add them, it's positive 0.05. You see? It's like 10 minus 5 is positive 5. You got it? Yeah, I see where you thought there was a 0 there. Any other questions? Okay, I'm going to stop there. So we are done now, pretty much the end of chapter 1.